today's topic is all about types of scheduling algorithm with an example. So let's see. First one is first come first serve. As we have seen, first come first serve is the type of non-preemptive scheduling algorithm. So in that, the process which enters the queue first will get executed first, will get the CPU first. So here P1 is arrived first, so it will get executed first, then P2 and then P3. So this chart that we have drawn is known as NAT chart. These are the burst times of the processes, and it is measured in millisecond. In our previous video we have seen what is burst time. Then comes SJF. You know what is SJF? SJF stands for shortest job first, and it is also a type of a non-preemptive scheduling algorithm. Now here we see the processes has arrived, but whichever is having the smallest burst time. See, P3 is having the smallest burst time, so it will get executed first. So first will come P3, will get executed, then after that P2 is having smallest burst time, so it will get executed, and then P1 will get executed. Now this was a non-preemptive SJF. Now we will see priority, which are of two types: priority for non-preemptive and priority scheduling algorithm for preemptive. We'll consider the same example but with the priorities assigned. Suppose P1, P2, P3 with time 24, 3, 2. So P1 is having priority, suppose 2, P2 is having 1, and P3 is having 3. So in this case, see what will happen. In this we will see whichever is having a highest priority. The lowest number is considered to be a highest priority. So we will execute P2 first. 0 for 3 milliseconds. Then after that P1 is having the highest priority. P1 will get executed, and then P3. So something mistake I have done. P1 3 plus 24, 27, 29. Then we will see. Now this is all about priority scheduling algorithm, which is non-preemptive. Now we will see what is the case in preemptive. Same example: P1, P2, P3, 24, 3, 2 with the priority 2, 1, and suppose 0, and suppose the arrival time of P1 is 1, 2, 3. Okay, so when 1 and 3, so let's see what will be the NAT chart of this. So P1 arrived and P2 arrived at the same interval. So we will see which one is having smallest priority, P2. So P2 will get executed for 1 millisecond. Okay, then we will see for 2 milliseconds nothing has arrived, so we will execute P2 only. Okay, for 2 milliseconds. burst time will get cut. Then we see at 2 millisecond nothing is arrived, then again P2 will get executed. Then at 3 millisecond we have P3 arrived, which is having low priority than P1. This has got executed, so we will not see this. P1 and P3, which one is having highest priority? P3. So we will execute P3 for 2 millisecond, and then P1 the rest of the 24 milliseconds. So this is about preemptive priority scheduling. Now we will see preemptive SJF, which is known as shortest remaining time first. S known for shortest, R for remaining time first. Same example, P1, P2, P3, 24, 3, 2. A new thing which comes here is all about arrival time in preemptive scheduling. So suppose 1, 1 and 2. Okay. Now which one is having shortest job? P2 is having, so P2 will get executed. They have arrived at the same time, P1 and P2. So we will check which one is having smallest burst time, P2. So we'll execute it for 1 millisecond. This will become 2. Then at 2nd millisecond, that is 2 millisecond, P3 arrive. Now they are having equal priority. So we will go in a FCFS fashion. P2 has arrived first. So P2, 2 millisecond. So this will cut, become 1. 1 is less than 2. So we'll again execute P2 for 1 millisecond. Then comes, we will check P3 and P1, which one is having lowest this burst time? P3 will get executed, and then P1. So I hope you understood this preemptive SJF. It's very important. If two processes have equal priorities, so or equal burst time, so we have to consider in FCFS fashion. We have to go in a FCFS fashion. Like here we have gone, same thing we have to do. Okay. Then comes round robin scheduling algorithm. It is a type of a preemptive scheduling algorithm, and in this fair chance is given to all the processes, and each process is assigned a time quantum. For that particular time quantum, the process get executed and then leaves the CPU. So consider same example, P2, P3, 24, 3, 2. Okay, and the time quantum is, suppose the time quantum is, first we will see the arrival time. So the arrival time is 1, 1, 1, 1 and 2. Okay, and the time quantum is, no, there is no need of arrival time here. Time quantum is 2 milliseconds. Okay, so let's see example how to solve this. We'll draw a NAT chart. In this, first 24, so P1 will execute for 2 milliseconds, then we'll leave the CPU. Then P2 will come, execute for a time quantum of 2 milliseconds. We will go on cancelling, minusing the burst time. 24 minus 2 is 22, and here remains 1. Then comes P3, 2 milliseconds. So this is done. Then again upper it comes P1 for 2 milliseconds, again 8 becomes 20, then P2 for 1 millisecond because there is no burst time left, so it will execute only for 1 millisecond. Then after that P1 will execute for the remaining 20 milliseconds. Okay, so that was all about types of scheduling algorithms with an example. I hope you all understood. So first is FCFS, second SGF, priority, non-preemptive, preemptive, SRTF, also known as preemptive SGF, and round robin scheduling algorithm. You have seen it with the help of all the examples. So I hope you all liked it and you understood. If you all liked my video, don't forget to subscribe. And see guys, if you all are watching it, so you all should subscribe. I mean, there is no use like if you are watching it and you are not subscribing it. So I recommend you all please subscribe. Thank you. Bye bye.